Hello YouTube, this is the Atlanta Puzzler and welcome to my channel. This week I wanted to start a new video tutorial titled Advanced Megaminx Tutorial. And what I want to talk about is sort of elaborate upon the last tutorial series that I made titled How to Design Your Own Megaminx Using Onshape. I sort of wanted to build on top of that and discuss what more you can do with that design, how you can get more advanced puzzle designs out of it. And particularly I'm talking about the Megaminx type puzzles or the dodecahedral type puzzles like the Starminx or the Pyraminx Crystal. I'm not going to discuss how to build a Starminx or Pyraminx Crystal in this series. That will be way too complicated, but I will in the future. I just wanted to do the series first to kind of talk about the big picture and how they relate to a Megaminx and why you need to understand how the Megaminx works and how cutting the different types of cuts, puzzle cuts work. And that will be like a prelude to building your own Megaminx or Starminx or a Pyraminx Crystal or and what are conical cuts and cylindrical cuts. And some of those topics are definitely advanced, so this tutorial series will be advanced. My last tutorial series, how to design a Megaminx, I would rate it at intermediate because, if you know how to make simple puzzles and getting into the Megaminx and dealing with all the, angles related to the dodecahedron is what I consider intermediate. But this is definitely an advanced. So if you don't know how to make a Megaminx, I would highly recommend you watch that tutorial series. So before we get started, there's a couple of things I wanted to mention first. NK Cube mentioned me in the last video of his tutorial series, and I really wanted to thank him in this video. I want to say I really appreciate it. I appreciate you refer your viewers to my channel. To be honest, for a while I thought my words were disappearing into the ether. So it's good to know that someone else was listening. So I really appreciate it. Thank you very much for the kind words and for the referral. And the other thing I was gonna also mention is also NK Cubed recommended these tools in one of the comments on one of my videos, but also he talked about them in his tutorial, and I think the first part of his tutorial series. And these are DeSouza's tools, and you can see the name there, feature from DeSouza's tools. And I'm sure if you're watching this video, then you know exactly what they are. But I just wanted to mention that I got them and started using them in case when you see me use them here or here, that I started using them. And I noticed that it says version 9.5, and typically in the software world that means it's well maintained. I mean 9 major revisions and at least and a number of many more minor revisions. That means it's pretty stable, pretty refined, and lots of features, which is great. So I'm excited to start using them. Okay, now to get to the tutorial, in part one, what I really wanted to talk about is what does it mean when I say the different cuts, and what is a cut, and what does it mean to modify the cuts to get a different shape of a puzzle. So if you remember from the Megaminx tutorial, when you build a puzzle, you basically make a sketch, which you're looking at one, and then you revolve it, and you get a disc, and then you pattern that disc, and then you dice or you split your solid with those faces, and then everything else is just cleaning up and filleting and whatnot. So really the heart of the design is the sketch and the patterning the sketch along all the faces. Now I know I'm simplifying, but this is the majority of most puzzle designs. So when you look at the sketch, you'll see two parts in it. One is the straight line that is external to the solid, and that is known as the cut itself. And the other part is these internal kind of zigzaggy parts inside the puzzle itself, and these are known as the mechanism. And there are many well-known mechanisms out there. For example, the V cubes have their own mechanisms, and those mechanisms can vary independent of the external cuts. For example, think of a store-bought Rubik's Cube and Thunderclap Speed Cube. They're both 3 by 3 cube, and externally they have, the same, more or less the same look. But when you take them apart, internally they have completely different mechanisms. Typically, speed cubes have anti-pop mechanisms and things that help them turn faster, and so that they cut corners and not get lock and whatnot. So in this series, I'm not going to be discussing the mechanisms for two reasons. One is that's a whole involved topic on its own. I can discuss what I know in a separate series, but also because I'm not really an expert in the different type of mechanisms. I just know a couple, and that's what I use. So what I'll be talking about is just this external part, and I think once we cover that, we can start talking about other puzzle designs. So if you look at the standard Megaminx sketch, you'll notice that I have a 7 millimeter dimension here, and what that is basically the distance between this upper face over here and the cutting profile. And what a cutting profile, what this line is essentially is this, if I revolve here, my computer is loading, so I'm sorry, it's a little slow today. So when you look at the revolve here, it's spinning, I'm sorry. I just want to show you the cutting profile. It's basically, that straight line represents the brim of the disc itself, and this little tiny cylinder is the mechanism itself. So I just want you to focus at the large disc and its relative to the solid, and how you notice the disc is parallel to the top face here, this top pentagon, and look at how deep or how far into the solid, I'm defining it, so I can push it down, than the body further into the body, the dodecahedron, or I can move it upwards closer to the surface, and that will tremendously change the shape of the puzzle. So currently the distance between this brim and the upper face is 7 millimeters. And just to show you really quick, if I reduce the distance, say 4 millimeters, and do OK, I'll still get a Megaminx, and it's still gonna work, and you can 3D print it, and it's fine. But you'll notice that my centers become huge, the pentagons are pretty large, the corners are small, they're tinier. If you look at the edge, the height of my edges shrunk. They're only 4 millimeters now, but they got, their width is much larger now. They're longer. So cutting closer to the surface reduces the size of my top layer, which increases the centers. What that means, if I go in the other direction, my center should get smaller. So let me crank this up. We were at 7, right? So let me make it 8, for example. And now you'll see we traveled further along the face, the side of the dodecahedron here. And when I do OK, you will see that my centers will get smaller, and my edges will get smaller, and my corners will get much larger, sort of the negative effect. Now this looks like a Starminx, but it's not actually a Starminx. The Starminx has the pentacles, or the stars. The pointy tips of the stars are the corners, sort of like the star, but rotated by, I guess, 72 degrees, or something like that. I'm not sure. Yeah, by maybe 45 degrees. I'm sorry. So if you look at this is still my edge, and the only difference, it's kind of pinched at the center, so the outer surface just has two distinct triangles. And my center got smaller and my corners are now massive, right? So for example, let me hide this corner and show you my edge is just my edge, and here it is, and it's fine. It looks the same, as just it has this pointy center now. So let me show this piece. Great. Let's go back to the sketch. And if I keep increasing this distance, after now at 8, it's sort of like they're pinched. Let's try, I don't know, 9.5 maybe. And do OK. And it's loading, so bear with me. Sorry, it's there's a lot of moving parts in this puzzle, so it has to recut everything and reprocess everything. But what you'll notice now is I'm getting this odd looking shape. But first of all, the corners are still massive and the center got smaller, but now my edges have a very irregular shape. It has like two bow ties looking thing, but it is still an edge of a Megaminx. So for example, sorry, it's loading. Okay, let me hide this again. And actually, you know what? Let me choose this, and this, and do hide other parts. And let's take a look at these. You'll notice that this is still a corner, and you see it. Look at the mechanism here. It's still a corner of a Megaminx. And if you look at this here, it's still a center. Sorry, this piece is center. It has a stem here that, doesn't have enough area to drill a screw in it, but it's still a center of a Megaminx. It's just very small. And the edge is still an edge, like you'd expect. And it has the mechanism here attached to it and everything. But it is missing a piece. Let me hide these as well. And if you look at it, well, first of all, the mechanism is not, the mechanism isn't very robust here. I mean, it has two little pieces here that are detached, so that is not good. Another thing is the piece, that diamond looking piece, is not attached to it anymore. There's a piece somewhere at the top that I don't have it showing that is hidden, and it's not attached to it, and you cannot get it to you cannot get it to stay. If you are to 3D print this puzzle, the parts here above this edge will not stay, so they're gonna fall apart. If you're not sure what I'm talking about, I'm referring to this part here. So if I do hide other parts, it's this little piece. This piece sits on top of the edge and it's not attached to the edge, and you can't glue it in place on the edge. If you do, some of your faces will not turn, so you can't really build this puzzle. So okay, let me show all parts and go back to the sketch, and let's center the view again. Okay, let's take a look again. So 9.5, you notice the reason why my faces got smaller at 9.5 and why they continue to get smaller is because the area in which, or the point in which the cutting profile or the brim of the cutting profile and this axis, when I say this axis, I'm referring to this colored axis here, not the axis of rotation, it's the adjacent axis over here. The point in which the two intersect, the brim or the cutting profile is above the axis, and they intersect outside of this body of the dodecahedron. Okay, so that forms this sort of triangular right triangle area here. If you know what if you're talking about, let me add a point here. I'm just gonna arbitrarily place a point here, and I'm gonna click on it and click on my cutting profile and make coincident and see. Okay, so I'm referring to this circular point, and if you notice, if I add a line and make it a construction line, let me draw these three triangles real quick. I'm referring to this triangle. There's this triangular area. This area is what causes the various shapes of the pentagon, basically the different sides of the center to be formed. So if I keep moving this downwards towards the bottom of the screen, so for example, if I make this 11, you notice the triangle is shrinking, and at some point the triangle will disappear forever, right? So here it is, it's getting smaller and smaller. So if you want to know exactly which point is that, it's the point where sorry, my computer is loading. So it's the point where this point of intersection is flush on the surface of the puzzle. In other words, let me go ahead and delete these construction lines, and it seems like I lost my point. Let me do it again. Okay, so I want to make this point and my line coincident, and then I'm going to click on the point and the face of the puzzle and make them coincident as well. And I'm getting an error probably because of the 11 here, the dimension. Let me delete it. And if you look now, they're intersecting exactly at the face of the puzzle. Perhaps I can go normal. No, sorry. I was trying to go normal to this other face, but anyways, it's basically they're flush exactly at the face of the puzzle. But something else you should know, basically they are flush on the face, but they're also smack in the middle of the centerpiece, and that will basically reduce the size of the center, the external surface area of the center, to 0. So let's take a look at that. And I think you know what the answer is going to be. It's going to be a Pyraminx Crystal. You'll see it now once it loads. It's spinning. But basically, when you look at this puzzle here, it looks exactly like a Pyraminx Crystal. And in fact, this is exactly how we'd model the cut of a Pyraminx Crystal. Now, that doesn't mean that the mechanism here is sound. It doesn't mean that you can 3D print this and say, hey, I have a Pyraminx Crystal. That's just the external cut, right? Now, if you print this, it's going to fall apart. The pieces won't be held together properly, and that's because the mechanism is not sound. And I can, in future videos, I will talk about the Pyraminx Crystal and mechanism and how you can make it work. And it's an involved topic, and basically you have to nest multiple puzzles within one another. And it's a topic I can't say I'm an expert in, but I'm pretty familiar with it. So I was gonna just share what I know and see what you guys think. Okay, so I guess the takeaway from this video is if you cut along anywhere under this edge, you'll get a standard Megaminx. Is just it's up to you how deep you want to make it, as long as you're above you're above 3/4 of the face, somewhere here. I think they'll give you a standard Megaminx. Once you cross maybe halfway here in the upper half of this face, so somewhere around this point and this point, somewhere along this way, once you cross, you're going to get this weird looking overlap with the top of the edges not being held in place. And you can continue the cuts until you reach the center of the face, and then you'll get the Pyraminx shape here externally. So that's, I guess, what I wanted you to know. Like this, if your cutting surface passes through the center, you'll get the Pyraminx. And since I got you here, let's I guess let me hide other parts and show you. So basically this would be a corner here, and this looks like a valid corner, but this looks like an edge that is invalid, right? So let me hide. My computer is slow, so forgive me. Yeah, it's not responsive. Okay, let me clear this and let me hide. Okay, so you look at this piece. Yeah, this is not gonna work. This has nothing to grab onto. It's just gonna fall off. Okay, so this video is getting too long, so I'm gonna stop here, and I'm gonna continue in the next video and talk about what happens as I travel further down the face, and what kind of shapes and changes you can do with the puzzle. So I hope you enjoyed this video. I know we didn't actually make any puzzles, but I hope this was informative and will get you to look forward to the upcoming videos and upcoming series for that matter. And let me know if you have any questions. We can talk about other cuts in part 2 of this series. So have a good night and thank you very much.